Hi everybody, this is Ms. Segovia and I'm going to work you through problems 2, 4, and 6 on free fall set 1. Question 2. At the top of a raised platform, a ball is thrown vertically upward with a speed of 37 meters per second. The ball rises up then falls to the ground below the platform with a downward speed of 85 meters per second. For how much time was the ball in free fall? So let's start out here with our guess method. Our givens for this equation are our initial velocity, which is 37 meters per second, and our final velocity, which is 85 meters per second. We also show you on the side of the worksheet that the acceleration due to gravity is 10 meters per second squared. The equation is asking us to solve for the time, so time is our unknown. Our equation that we're going to use for this one is a little varied. We're going to actually use the equation for acceleration. Acceleration equals our change in velocity over our time, since that's utilizing all our variables. And we need to first solve for our change in velocity. So to solve for change in velocity, we have to take our initial minus our final. So initial velocity minus our final velocity. So we have our 37 meters per second minus, now over here our final velocity, I put 85, but if we go back to the problem, it says that it's a downward speed of 85. So that means our 85 over here is actually a negative 85. So we're going to take a negative 85 and subtract that from 37. Well, if you remember your rules of mathematics, when you subtract a negative, you're essentially adding it. So when you add those two, you get 122 meters per second. So our delta V is 122 meters per second. We can now put that into our equation over here, which we're going to solve for time. So let's rearrange that one really quick. Time equals delta V over acceleration, and then we're going to have 122 meters per second divided by our acceleration, which is 10 meters per second squared. When you work that one out, you don't even really need a calculator. That one is 12.2. And if we want to find our units here, we have meters per second is going to cancel with meters per second and our squared. So we end up with 12.2 seconds for our final answer for question 2. On question 4, an object is released from rest and falls with negligible air resistance. How fast is the object falling after 3 minutes? Well, let's go back to our guess method. Our givens for this equation, we have time is 3 minutes. We have acceleration, which is 10 meters per second squared. Oh, wait a minute here. We've got minutes here and meters per second here. So that means we're going to have to change our time to seconds. Well, with 60 seconds and 1 minute, take 3 times 60 and we actually have 180 seconds to use for our time. Our unknown for this equation is our velocity, because they're asking us how fast is the object traveling. So when we look for our equation, we want to look for an equation that has velocity, acceleration, and time. And that one would be velocity equals acceleration times time. And so we can plug our numbers in here for our sub and solve. Acceleration is 10 meters per second times time, which is 180 seconds. And our final velocity for our solution is velocity equals 1,800 meters per second for our final answer. That was almost too easy, wasn't it? Alright, last question I want to work with you is question 6. A rock is dropped from the top of a cliff, reaches the ground moving with a speed of 30 meters per second. How high is the cliff? So if you wanted to imagine that one, looking at our cliff, draw a little sketch for you right here. We've got our cliff, and then somebody throws a rock, and it comes down here. So they want to know how high is it from this point to this point. Well, the height is also known as distance. So we're going to solve this one for x. So let's go to our guess method again. Our givens for this one, we have our speed is 30 meters per second. They give us on the side our acceleration is 10 meters per second squared. And again, our unknown, we are solving for x. So if you look at your equation chart, you will find an equation that has all those different variables in there, and that one is v squared equals 2 times acceleration and displacement. To rearrange that one to solve it for our displacement, our x factor here, we can put x equals v squared over 2 times acceleration. And then we simply substitute our numbers in. So we've got x equals v squared. Our velocity again was 30 meters per second. We're going to square that, divided by 2 times our acceleration, which is 10 meters per second squared. Now it's kind of interesting when we work this one, we're going to end up with 900 meters squared per second squared divided by 20 meters per second squared. When you work that one out, you're going to come out 900 divided by 20 is 45. But then our crazy units here, let's go ahead and cancel some of these out. We can cancel meters with our squared meters, so we end up with meters on the top. Since second squared cancels with second squared. So our final answer is 45 meters for the height of our cliff. The 8th problem right here, I was going to work with you guys, but we actually did that one in the lab in class where you guys caught the ruler. So using the information from our lab that we did, you guys should be able to solve this one. If you have any issues with it, let me know and I will help you out. Thanks for your time.